So by now you should be used to the idea of anti-power rule for taking definite and indefinite integrals. So let's do one practice with that. Let's say we have the definite integral from 0 to 1 of x to the third over 5 plus x squared dx. So again, we're just going to use the anti-power rule on each term in this integral, or on the integrand, and take the integral that way. So x to the third over 5 becomes x to the fourth over 20. Again, we multiply, or we divide the power that we get, and if we divide a fraction that is already a fraction, we multiply the denominators and it becomes 20, plus x to the third over 3. And this is from 0 to 1. And so this is equal to 1/20th, or 1 to the fourth over 20, which is just 1/20th, plus 1/3, minus 0 minus 0. These are nothing, so this is just 1/20th plus 1/3. And if we want, we can simplify this fraction and actually add it together, but we don't need to. So that's the anti-power rule. Now, let's discuss an integral where we cannot directly take the integral using the anti-power rule. And that's where we're going to introduce something called U-Substitution, or sometimes known as just substitution for integrals. Let's say we have the definite integral from 0, again we'll just do 0 to 1 to simplify things, of 2x over the square root of x squared minus 1. Alright, so in this case, we can't really do much, right? Because we can't, if this was just x squared, so like for example, if it was 2x over square root of x squared, sorry, I forgot dx. If it was 2x over the square root of x squared, well, this just simplifies to 2x over x, right? Square root of something squared is just that, and this just simplifies to 2, and we can easily take the integral of 2. However, in this case, we have 2x over the square root of x squared minus 1. So we actually cannot take the integral of this integrand essentially directly. So we have to use something called U-Substitution. So I'm just going to use U-Substitution for this problem, and then I'm going to explain it more in detail afterwards. So what we're going to do is we're going to say let u, again we're doing this to make this integral possible to do by hand. We're going to say let u equal x squared minus 1. Again, this might be a bit mysterious, but just keep watching. And if we take the derivative of our function u, and that's just du would be, well, the derivative of this with respect to u would be 2x minus 0, right? Because derivative of 1 is just 0, and then dx. So you might see where I'm going with this, maybe not, just keep watching. Now, what we do is we know that du is equal to 2x dx. And 2x dx is actually this term right here. This is du. Let me write that d better. This is du. Okay. And we also know that whatever's inside the square root is u. Now, we have to change our bounds here because we let u equal x squared minus 1. So when x is 0, u is, well, 0 minus 1. So for when x is 0, u is negative 1. And then for when x is 1, let's see, we plug in 1 here, we get 1 squared minus 1, u is 0. So we can rewrite this integral, so bear with me here, we can rewrite this integral as the definite integral from negative 1 to 0 of du, again, du is 2x dx, right? So du over the square root of u. So pause the video here, look at what I did, and just confirm that it is equivalent. All right, let's keep going. So we can rewrite this as the definite integral from negative 1 to 0 of 1 over square root of u du. So this looks more familiar now. It looks like we can potentially use the power rule, so that's good. The anti-power rule. Okay, so this is equal to, well, the square root of u is just u to the 1/2. We can bring it to the top, making the power negative. So this is the definite integral from negative 1 to 0 of u to the negative 1/2 du. Now from here, we can actually just use the anti-power rule. So notice we made this integrand that looked impossible to do by hand. We made it possible by doing a U-substitution. And so let's finish this off and then I'll explain a bit more on what we did. Well, now we can just add 1, right, using the anti-power rule and divide by the power. So this becomes u to the negative 1/2 plus 1, which is 1/2, divided by 1/2, which means we can multiply by 2 from negative 1 to 0. Now in this case, it seems like actually this integral is going to be imaginary, because if we evaluate this, so if we get, it's going to be 2 times 0 to the 1/2 minus 2 times negative 1 to the 1/2. So in this case, this is a bit complicated because this integral is going to be imaginary because of the bounds. And so the answer to this area is actually imaginary due to some domain restrictions, but we'll get into that once we get to improper integrals, which is what this was. But the idea still holds with the U-substitution. So let me explain what we did here. So essentially what we said is we let u equal x squared minus 1, because we knew that the derivative of u is going to be whatever is on top, 2x dx. And that allowed us to actually take the integral of this integrand by hand. And that right there is U-substitution.